Hey everyone, let's take a look at this section 9.4 homework, question number 3. So as you can see, here's our section 9.4 and here's question number 3. So as you can see, we are obviously talking about hypothesis testing. The question has multiple parts to it, but I'll show you the main part, which is calculating the p-value. So you can see here the question says, you wish to test the following claim, H sub A at a significance level of alpha equals 0.001. You've got your hypotheses listed here. So we've got the null hypothesis H sub 0, where mu is equal to 80.7, and the alternative hypothesis H sub A, where we have mu not equal to 80.7. You believe the population is normally distributed and you know the standard deviation is sigma equals 14.4. You obtain a sample mean of M equal to 76.8 for a sample size of N equal to 60. What is the p-value for this sample? Report an answer accurate to 4 decimal places, and then we have a place to put the p-value in. And then once you calculate that p-value, you will see they're asking you if the p-value is less than, equal to, or greater than alpha. This test statistic leads to a decision to reject the null, accept the null, or fail to reject the null. So you have to choose between those options. And then the final one says, as such, the final conclusion is that, and then you have 4 different multiple choice options to choose from. So once I think you calculate the p-value, you guys should be able to do the remaining 3 multiple choice questions. So I will not go over those, but I will show you how to calculate the p-value. So again, I've created a Google Sheets spreadsheet to help us out with that. And I'll share the link for this with you guys. So again, if you want to use this worksheet, you will need to download it or make a copy of it. But you can see I copied the problem over here. It's just an image of the problem, so you guys have something for reference. But if you scroll down, I wanted to show you that question like this. Of course, here we are given the two-tailed test here, right? Because you have mu equal to and mu not equal to as part of the hypothesis testing. But sometimes you can have a left-tailed and a right-tailed test as well. So where you may have mu equal to for the null hypothesis, but then mu less than for the alternative hypotheses, or you can also have mu equal to for the null hypotheses and mu greater than for the alternative hypothesis. So then you will need to know, are you looking at a left tail test, a right tail test, or a two-tailed test? So in our example, we are definitely looking at a two-tailed test over here, right? Because they said mu is not equal to. And then of course, you need to fill in all of your information. So you will see in the problem, they are telling us the sample size is 60. So n equals 60. I've went ahead and entered that in my spreadsheet. We have m equals, which is the sample mean, 76.8. So we've got the 76.8 for our sample mean. Of course, in the null hypotheses, we are given that the mu is 80.7. So we've got 80.7 in our spreadsheet. The standard deviation is given to us as 14.4. So of course, we've got that for our sigma value, 14.4. And then your alpha, the level of significance, was given as 0.01. So I've got that in there. And I went ahead and divided the alpha by 2 and did 1 minus alpha by 2 in case you guys were interested in using the standard normal table to figure out what your z-score is. But, again, I just prefer to use technology if I can instead of a table, but obviously you have that option. So our first step is actually going to be to calculate the z-score. So you can see the formula for the z-score over here, which is m minus mu on the numerator divided by sigma divided by square root of n on the denominator of this fraction. So you actually have a fraction in the denominator of the z-score calculation, right? So we're doing subtraction on the numerator, and then we're doing a division with a square root on the denominator. So I went ahead and did the numerator and denominator calculation separately. So you will see I have my m minus mu, which is 76.8 0.8 minus 80.7. So you can see we came up with a negative 3.9 as a value of that subtraction. And then when you did sigma divided by square root of n, which was 14.4 divided by the square root of 60, we came up with 1.859032006, right? And now when we divide these two values, you can see our z-score comes out to be negative 2.098. So I'm actually going to copy this number, and I found this p-value calculator online, which actually makes our calculations really easy. Because like I said, then you don't have to worry about using a table. So I'm actually going to copy and paste our z-score from the Google Sheets here. So we have, remember that was negative 2.098. I'm going to paste that here in our calculator, and I'm just simply going to click on compute the p-value. Now remember, this was a uh, two-tailed test, right? But you will see by default, the calculator was on the right tail. So we do need to change that. And we need to say two-tailed, and you will see how that p-value changed. So again, if you're on right tail, you will see you have a different p-value. If you click on left tail, you will have a different p-value. And then when you click on two tails, you will have a different p-value. So it is very essential you remember which type of hypothesis testing you are doing and choose that p-value type correctly. And then, of course, you will see it's going to show you a little graph here just to go with, what the normal distribution will look like in this case. And then once you have your p-value, we can come back to our problem. We can paste it here and check our answer. Now, obviously, since I haven't done the remaining parts, you will see that I only get partial credit. But the important thing is you will see we did in fact have the correct p-value over here. And then just to make sure I have that in here, looks like I've actually got a, different answer in there. So let me delete that and make sure I paste the correct one so you guys have something for reference. And then you will see, that this was in fact our correct answer. Now, I did not reduce it down to 4 decimal places, but you will see that it did accept our answer over here. So now we have the p-value. You should be able to go ahead and answer the remaining 3 multiple choice questions. So I hope this helps you figure out how to calculate the p-value for a population based hypotheses testing. So again, guys, if you have any questions, please let me know. Take care and good luck, everyone.